Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. I believe you all are fine. So today we are going to discuss a multiple choice question presented in front of you. Such kind of question could be useful for any college or university level chemistry related exams like BSMS, B.Sc, M.Sc, or competitive exams like CSIR-NET, GATE, IIT-JAM, even for advanced IIT-JEE advanced or NEET like that. Okay, so that's why I made this question. So you have to answer what is the final product. So as usual, I first request you student that please read the question carefully, pause the video and write your answer in the comment box. Don't hesitate, it will be right or wrong because you need to accept your situation. And most importantly, remember one statement: self-evaluation is essential for improvement. Okay, I guess you people are already habituated with this dialogue. Fine. So I believe you have paused the video and tried by yourself. So it's my turn to give you the first. I shall explain what is the product, and at the end I shall explain how to solve this question less than 30 seconds. By the way, before going to details, I have a small request. If you really enjoy my teaching, if possible, please support me through Patreon. And another request is that please subscribe this channel, because I have observed many people watch this channel but they don't subscribe. Please do this, it helps a lot, it motivates a lot. Okay, so let's come to the point. Now, whenever any question if you find in your exam, please keep few points in your mind. Try to understand, in case of MCQ, what reagent is given and what type of functional group present in molecule, or possible what reaction is happening here. Okay, first of all, look at that. And in this case, when multiple step reactions are given, it is obviously good to go step by step. Now, see, this is a sodium liquid ammonia ethanol THF. This is nothing but Birch reduction. Okay, I have already uploaded dedicated lectures, many lectures on Birch reduction. Please visit them for your better understanding. And in this case, this is actually Birch reduction on electron donating or electron releasing adenine. Okay, so this is a special category. I have uploaded a dedicated lecture on this category also. Okay, why I am saying it's electron releasing? Because of this OMe group, because it delocalizes slowly here. Okay, now question is where the reaction will occur. First of all, reaction will occur in the whole molecule. Okay, generally what do we believe? That this middle part, this is a 9-10 position of anthracene. Okay, it prefers to undergo reaction, because aromaticity, then what it produces this 9-10 reduction. So these two rings are aromatic. But by the way, for such kind of problem, it is better to start from the electron bridge, because this is in this way reaction happen. Just consider, if you take a phenyl methyl ether and you do the simple Birch reduction, what is the product you expect? I haven't said workup, just Birch reduction. This is OR, this is OMe, better to say here. Fine. So this is, so first draw this. So see, one double bond attached to this OR and another is exactly opposite. So one double bond attached to this, this is OMe. Let's clean it. Okay. So this is OMe, this is this. But generally one statement, remember, Birch reduction is an electron donation to the aromatic nucleus. So it is preferred which nucleus is less electron rich or electron deficient, that will be reduced first. But for such kind of problem, this strategy I am saying such that the probability of mistake is less. Otherwise, it is highly expected reaction start from 19 position. Fine. This. Now, just consider this. Then what is the option left? This. Only this ring got reduced. Fine. What about naphthalene? Naphthalene also, if you look at naphthalene, what undergo Birch reduction, what it produces? It produces this. Okay, because one ring first reduces, the loss of aromaticity is less in this case. So in this case, what you can expect? That this will reduce into this. Now still one ring aromaticity persisting. Reaction will not stop here. So reaction will. Now one important info, that whenever generally we do any organic reaction, we mention the stoichiometry. But you observe in anywhere the stoichiometry of Birch reduction generally not mentioned. So there is a different strategy. So don't be confused about this thing that it is not mentioned. So one equivalent reaction, no, it will not stop. Second thing, this reaction is a sodium dissolved in liquid ammonia. It's a very reactive reagent, and liquid ammonia, this term indicates that reaction temperature less than -33 degrees centigrade. Okay, means it's a boiling point of ammonia. So reaction is drastic and reaction will continue until everything is consumed. Okay, fine. So this is the ultimate. Now question, further reduction possible? Obviously not. See, these double bonds are isolated, and this you can say conjugated, but it's conjugated with electron rich. So it is reluctant to take any electron, and we know Birch reduction, this OMe not reduces. Just I showed at the beginning what is the product of Birch reduction of phenyl methyl ether. So this is up to the step 1. Now what about the next, acidification? See, when you do the acidification step, then what happens? This position. So first of all, what happens? This acid HCl, this get protonated. Is it? No. Why? See, this is a double bond, this is OR. It has a vinyl ether, it has a canonical form. This pushes, this goes. So OR, this negative charge. So this is, so the double bond is actually abstracts the proton. So it abstracts the proton, H plus. Okay. So in next step what happens? This proton get attached here, and it produces a carbocation which is resonance stabilized by the conjugation of OMe, and ultimately what it results this, because in this structure the octet is filled. Next step what happens? H3O plus means there is water. Generally dilute HCl is used. So this is HOH, dilute HCl or H2SO. It opens up. So ultimately throughout this process, so first step it will produce OH, OMe neutralization. Then there is on again H plus, so it will protonate, and that time it will push, it will leave, because after protonation it became a good leaving group. Okay, before protonation it is not a good leaving group, but remember after protonation it's a good leaving group because the leaving group is neutral. And by the way, I have uploaded a dedicated lecture on the nature of leaving group in nucleophilic substitution reaction. Please visit that lecture. I guess if you have any doubt on this concept, it will be cleared. This is after removal of proton from this oxygen also. So this is the end of step 2. So question, what about the step 3? Now step 3, if you need to understand, little bit about this acid, perchloric acid. This perchloric acid is a very strong acid. Why? When we say strength of any acid, then we need to consider what the conjugate base means, HClO4 minus, because see, ClO, see, chlorine is actually plus 7 oxidation state in this case. Now this oxygen is highly, this negative charge on this oxygen is highly stabilized. How? It could become here, it can open option 1 canonical form, it canonical form 2, canonical form 3, and see all canonical forms are equivalent. That's why this is a very strong acid. And by the way, this perchloric acid is actually a super acid. The physical significance of the name of super acid is very strong acid. And technically it is stronger than sulfuric acid. And by the way, I have already discussed a dedicated lecture on super acid. If you want to learn them in details, you may visit. Fine. So it is a very strong acid. Okay. So what is mean? That it will protonate other very easily. Means it is very interested to give proton. So in this molecule where it can give proton, two types of functionalities. One is double bond alkene, CC double bond, and another is oxygen. Remember, CC double bond is a soft acid. It's a soft base, whereas oxygen is a hard base. and proton is a hard acid. So what happens? This first get protonated. Fine. And since now when we say the protonation of carbonyl group, we say it's a reversible because it is not that much strong base. But there is another part. Is the acid is strong? Generally we use HCl, acetic acid like that, which are not that much strong compared to perchloric acid. So now because of perchloric acid, the scenario is little different. It will be completely protonated. Now when it protonated, the tendency of enolization increases. What do I mean by the statement? So this will be converted into the corresponding enol. Now look at that, from here to here to here to here, conjugated. So keto-enol tautomerism is in equilibrium. So in first step, what you can expect, that in equilibrium it will produce this. Now first of all, it's enol tautomerism. Again it can come to keto, but that will be conjugated, means this. Now this is actually, alpha beta unsaturated carbonyl. I have already discussed a dedicated lecture on this. Please visit if you want to learn their details property. Okay. And another thing, along with this, there is another terminology, that is principle of phenylology. Means principle of phenylology means if you have a double bond in between, the property shifts. What do I mean by this statement? Double bond act as a spacer. Means, for example, if you take a ketone and if you take a alpha beta unsaturated ketone, so this center, what property, for example, enolate generation, those things, means this center, this versus this. Let's remove this part. This is X something, I am not interested. So here enolate generation possible, similarly enolate generation possible here. Means this proton will abstract. Say only one difference is one double bond has a spacer. That means a vinyl group spacer. That's why principle of phenylology. Okay, this word means the vinyl group spaces property extends. So from this understanding, what we can conclude, that if vinyl group is double bond is there, property remains almost same. I will not say exact same, almost same. So what happens? There are two hydrogen there. Now similarly in the reaction medium there is perchloric acid. So still it could be protonated. Remember, this is in equilibrium. Okay, and tendency to be protonated is higher. So similarly what will happen? That again enol formation like that. You can consider that again these enol formation. Again it will come back to keto. Now see conjugation from here to here up to here. So again when it will come back, what it will produce? Again these double bonds will go and it will produce double bond, double bond, double bond. Similar phenomena will occur for this also, and ultimately it will result. Why this will stop here? Because further not possible. Okay. So not only that, if you can take logically another double this phenyl group, similar thing will have another. Now question, why these compounds are useful? See, because of this conjugation trans in beta carotene type molecule you can observe, and you can consider these are that antioxidant type property, antioxidant type property you can expect. By the way, I have already uploaded few lectures like glutathione, vitamin C, turmeric means curcumin as an antioxidant, even vitamin E. So please visit those lectures if you want to learn biological antioxidant in details. What do I mean antioxidant? Antioxidant means the molecule which itself is prone to oxidize and save the biological system or any reducing agent present in the molecule. Fine. So this is antioxidant, so you can do those kind of study using this conjugated molecule which acting as a electron reservoir, means they are electron rich. That's why they can prevent oxidation by getting oxidized itself, means sacrifices themselves such that the molecule which your target is safe. So this is the this is the final product. Now an important thing, look at, if you take this water, means dilute acid workup, where we have ended here, means a ketone derivative we can consider, means this one, see. But because of this perchloric acid, and see it's a 50%, means pretty strong perchloric acid, that's why reaction will end up here. So this is the interesting chemistry, please try to remember about this property. So what is the answer? Answer is D. Okay, so this now question is, if this thing appears in your exam, how can you solve it less than 30 seconds? First of all, this thing you understand, sodium lipidemia Birch reduction means excess generally happens. Another thing, for example, if you think it is 1, then in which case 1 equivalent reduction is there? Is there any example where 1 equivalent reduction? Here also 2 equivalent. Here also 2 equivalent here. So reaction will stop here. So this options indicating that this is not 1 equivalent. If you argue that, sir, it is not mentioned, so I shall consider that this is 1 equivalent. No, options are not there also. And in MCQ, it is a art that you need to understand. You need to look at very carefully about what options are given, because options will tell what is the right answer. Now fine. Yes. So this is question where the reaction will. Okay, fine. This will, after that, naphthalene means I students suggest you first you draw one molecule from that, do this. First this part will be like aromatic means ether. So this part. Second is a naphthalene part. So again this part, as I told in the beginning. Third this. So you can expect that you can first end up with this molecule. When second it's an workup means this part chemistry we know that oxidizes and produces this carbon. This much I want to find. Now what about perchloric acid? What is its unique role? It is a very strong acid, and acid resulted in ketonal tautomerism, and that resulted in conjugation. Means if a single time conjugation starts, see anywhere conjugation is not given means that way, but here started but ultimately end up this. So based on your logical understanding, the answer will be this. And if you know the chemistry completely, that's obviously means I believe it's a very good. Okay, so in this way, based on your common sense, you can end up with the right answer. And it is true, students, how much you read, you will be more enriched, more confident, that's fine. But sometime if you get any surprising question, different type, then you must depend on your gut feelings, better to say. So this is the result of gut feelings. So this is the end of this discussion. I believe this video may be useful. Please write your opinion on the comment box. And most importantly, if you enjoyed this video, please do press the like button because it motivates a lot. And if you think this video is worthy, then pass it with your friends because they can enjoy such kind of lecture in free of cost. And most importantly, if you really enjoy this channel, then please press the subscribe button so that you'll be notified whenever I shall upload a new video. So this is the end of this discussion. Stay happy, stay blessed. See you in my next video.